Okay, next lecture number 2, Kirchhoff's current law and Kirchhoff's voltage law. In the previous video, introduction about the chapter number 2, that is a KCL and KVL. In this video, we are going to discuss complete discussion about the KCL and KVL. Right, Kirchhoff's current law. By look at this scientist, Kirchhoff is a scientist, he is introducing these laws. Okay, what is the law here? In any, it state as follows: in any electrical network, any network, algebraic sum of the currents meeting at a point or junction, it is very important, meeting at a point or junction is zero. Okay, so look at here, this is a junction or node. All these currents meeting this particular point is to be zero according to the definition. So in this case, my assumption here, this is only assumption, incoming currents towards the node, incoming currents means towards the node or junction, it is make it as a positive. Okay, second assumption, outgoing current, outgoing or away from node, we can consider it as a negative. According to that particular notation, just look at this diagram. Incoming, I1 is incoming, right? Next, IT is outgoing, algebraic sum. Outgoing means that negative. Next, I3 is outgoing, that is a negative. Next, I4 is incoming, directly it is positive. I5 is outgoing, that is a negative, is equal to 0. All of you got my point. According to the statement, in any electrical network, the algebraic sum of the currents meeting at a point or junction is equal to 0. This is a statement. So, second one. In another way, it is simply means that total current leaving a junction is equal to total current entering that junction. So here the statement is similar, but the statement here, the total current leaving a junction is equal to total current entering into the junction. So it is obviously true because no accumulation of charge at the junction of a network. That means very, very important. There is no accumulation of charge at junction. So at junction, there is no accumulation for charges. So this is a point you need to remember. Coming to here, in the second statement I need to prove, or otherwise in the second one, incoming currents, I1 is incoming, right? I4 is incoming, okay? I1 and I4 incoming, and I2, I3 and I5 is outgoing. I2 plus I4 plus I5 is outgoing. This is a this is a KCL, incoming current is equal to outgoing current from the statement 2. Okay, this is also proven. So both the statements are same. I need to derive further here I1, right, plus I4 minus I2 minus I3 plus I5 minus I5. In the right hand side, it may be I2 plus I3 plus here I3. I'm sorry, I3 plus I5. Both are same or not? Both are same. So both the statements are same. Finally, you need to remember in the examination point of view, they provide the statement. This particular statement belongs to, or which particular statement belongs to, KCL or KVL? KCL. They will give Norton's theorem, KCL, KVL, otherwise Ohm's law. You can choose that is a KCL. That type of questions may expect. Okay, fine. So next, coming to here, in the second diagram, by looking at the second diagram, so the incoming current, that is IE, emitter current, is equal to outgoing currents are base current plus collector current. This is a KCL at node or base point. If you are applying for the transistor, this is the case, you need to prove that. So everyone is clear about the complete idea about the KCL. I hope that it is clear for you. Okay, next, another important point everyone note down. So the working principle of KCL, the working principle of KCL, the working principle of KCL is conservation of charge. Conservation of charge. It is very, very important. Okay. So next we are moving to Kirchhoff's voltage law. Okay. In the Kirchhoff voltage law, it is also called as a KVL. Right. First look at the statement clearly. It states as follows. The algebraic sum of product of current and resistances. You know, sum of product of resistance and currents means that voltage. So, you know, V is equal to IR. Sum of product of resistance and current is nothing but a voltages. In each of a conductor in any closed path or mesh in a network, plus the algebraic sum of the EMF in that path is 0. That means sum of the voltage, sum of the resistance and current plus sum of the EMFs is equal to 0. That is a Kirchhoff's voltage law. So it should be noted that algebraic sum is a sum which takes into account the polarities of the voltage drop. It is very, very important. You know, while you are taking the summation, it not to be direct summation based on the polarities of the EMFs. Polarities you need to take the consideration. EMF polarity or the resistance polarity based on the current direction, you need to choose that. So that is a condition to apply the Kirchhoff's voltage law. So in this case, you know, this is a loop we have. The polarities of this resistors plus and minus. My convention here, the voltage, the current or the loop current here mentioned, this is the direction, for example, that is I. How to make the voltages drops here? Negative to positive, and consider V1. Here negative to positive, consider V2. Again negative to positive, consider V3. All the polarities are same. Negative to positive, that is a Vs is equal to 0. This is a KVL. Sum of the voltages in a closed path is equal to 0. So here all the polarities are similar polarity. That's why all the voltages are summation only. There is no reverse polarity based on that. Okay. Next, coming to the determination of algebraic sum sign. Already just now I mentioned the summation is based on the polarities, right? So that polarities I will explain here. So everyone listen carefully. By look at this, before moving to all these concepts, just see here. It is clear that the sign of the voltage drop across a resistor depending upon the direction of current through the resistor. Very, very important. The polarity of the voltage drop of the resistor based on the direction of current. Okay, but independent of the polarity of a EMF in the circuit under consideration. If we are connected the EMF any direction, any polarity, it is based on the current flowing through the resistor only. Polarity of a resistor is dependent. It is a very, very important crucial point in your examination point of view. Okay, every concept you need to clearly understand, then only in the objective examination you might be success. You crack the examination. That's why I'm explaining clearly each and every topic mentioned in your KVS syllabus. Right, coming to here. So here the polarities of A and B, negative and positive, this is a rising voltage, right? Rising voltage concept is a plus E. Coming to here, the polarity, this is the arrow direction, the polarity of the current direction from negative to positive, that is a fall in voltage. It is a negative minus E in the equations. While you are considering the equations, negative to positive we can consider as a plus E, plus to minus you can consider as a minus E, right? This is a convention you need to follow. Coming to here, In case of resistor, the arrow direction, the current flowing direction, both are same. So whenever both are same, you know, minus V is equal to minus IR. So this is a fall in voltage. That means the arrow direction from positive to negative. So minus voltage is present. Okay, coming to here. This is the arrow direction. This is the arrow direction. Motion will be negative to positive. That is a raising voltage. That's why plus IR. So plus IR. There is no minus here. Plus IR you need to consider. Everyone is clear about that? Okay, it is a minus V. Clear, it is a minus V, it is a plus V. So you need to remember this particular assumption, but this assumption may be taken as a reverse also. In case of negative to positive can taken as a negative. In this case positive to negative can taken as a positive. So all these cases are reversible. Okay, throughout your preparation for KVS TGT work experience teacher, our main motive is to crack the exam. You need to answer the question properly, correct answers. That's why don't get confusion about those are enroll our courses. I will follow throughout my explanation. This is the convention. Okay, right. Coming to here, based on that convention, I am writing the equation for this network. Look at here. So coming to from negative to positive, right? Whenever this arrow direction, this particular arrow direction in the clockwise direction, negative to positive, that means that raising voltage, the raising voltage concept here taken as a plus E1. Next, coming to here, this current direction as well as this current direction, the direction of currents are motion of the particular arrow and current direction. See here, current direction both are same. What we need to do that? Minus IR. So minus I, what is the I here? The current flowing through this particular branch is I4 into R4. Got my point? Coming to here. So here, this is the direction, right? This is the direction. Arrow direction is same as this arrow direction. So it is a minus I1 into R1. Next, coming to here. This arrow direction, this motion arrow direction, this is the condition, negative, opposite. Whenever opposite fall in voltage, so plus raising voltage, opposite direction, right? Plus I2 into R2. Coming to here, this is the arrow direction is from positive to negative, fall in, right? Minus E2. Coming to here, this arrow direction is same as this current direction in the branch. So fall in voltage case, that is a minus I3 into R3 is equal to 0. This is a KVL equation. So you know, summation minus E1 E2 together. So E1 minus E2 is equal to R plus is equal to I4 R4, here minus, right? Minus I4 R4 minus I1 R1 plus I2 R2 minus I3 R3 is equal to 0. Okay, this is about the KVL explanation. I hope everyone is clear about this explanation about the KVL. Right, coming to the next one. Assumed direction of current. So here assumed direction of current, you need to remember these 2 points, it is enough. Okay, in applying Kirchhoff law to electrical network, the equation of assumed proper direction of current usually arises. So while you are assume the current direction, you need to assume the proper current direction. Okay. In case the direction of current flow may be assumed either clockwise or anti-clockwise direction. By look at the diagram here, I am assuming this is a clockwise direction. So in case of you are assuming, anti-clockwise direction is also possible. Anti-clockwise direction is also possible. What are the parameters are given assumption, these assumptions are reversed for that anti-clockwise direction. So here, if the assumed direction of current is not usual the actual direction, then solving the question, the current will be found minus sign. While you are finding out in the values of or solving the equations, you might get negative sign with our assumptions. Don't get panic. Our direction is opposite to that our assumed direction, but magnitude you got the same thing. That means your conclusion here, if you get the negative answers at any case, our assumed direction is opposite to the actual current direction, but magnitude won't affect it. Okay, right? So that's what you need to remember. Next one, if the answer is positive, that means then our assumed direction is same as actual direction. So there is no doubt about, if you get the positive, okay, our assumed direction is same as actual direction. Okay, that is the conclusion. However, one important point, that is, once particular direction is has to be assumed. In case of you take up the one question, you are assumed that what is the current direction is one direction, clockwise direction. The same should be used throughout the solution of the question. That means if we are assumed the clockwise direction in the same question, we are assumed in the second meshing anti-clockwise direction, we will get the wrong answers. So throughout the solution, you need to assume only one direction, only one assumptions, clockwise or anti-clockwise. That is a very, very important. Okay, in the examination point of view, few questions we need to see in the 2014 question paper, work experience teacher question paper. One of the question here, what is the value of E in the given circuit? What is the value of E in the given circuit? By look at the diagram, you need to find out the E. I will apply KVL to the outer loop. For example, this is the outer loop I have. So this outer loop, see here the current directions. This is the clockwise direction I assumed. This is coming from plus to minus, that means falling voltage, that is a 1 volt. This is a solution. Next, coming to here, positive to negative, that means falling voltage A. Here positive to negative, falling voltage 5. Here minus 10 is equal to 0. So from that, minus E is equal to 16. Coming to the conclusion, E is equal to minus 16 volt. What is the answer now? The answer here, minus 16 volt. Option A is the correct option. So in the examination also, any complicated network is given, don't bother about the network, what they given. But the concept, once you clear the concept about that KCL or KVL, any topic, definitely can answer the questions. You want this type of explanation for total entire syllabus of work experience teacher, you can go to our description. Mobile app link is provided in the description. Mobile app link is provided. Otherwise, it can Play Store you can type it Balaji space Inokunda. You will get our mobile app link. You can download it and then go to the demo classes. You can purchase it. So thank you.